Here we're going to work an example out of 2.1 homework. Several of us had questions or seem to be having a little difficulties with the frequency distributions. So let's look at one of the problems from homework. This is number 22 in 2.1. So they give us a set of data. So let's copy that set of data over. And this is for 24 doctors and list their retirement age. Yep. So they tell us that they want 6 classes, I believe. Yep, 6 classes. So we need to figure out what are our class limits. What are the edges of our class? And then they ask us for frequencies and things like that. So we need to find the lowest and the largest values. So just for practice, even though we're not told to do this, I'm going to do a stem and leaf plot. That'll help us find the lowest value, the largest value. It will help us as we count our data. So we have values in the 50s, in the 60s, in the 70s. So if we start at the first one, we have 50, we have 50, 55. So remember the way a stem leaf plot works. We put the values of the stem here, and then we put the leaf digit in the corresponding row. So we have another 55, a 57, a 79, a 60, a 62, a 61, 63, 66, 67, 69, 69, 68, 68, 65, 67, 50, 69, 70, 75, 71, and 73. Now, remember with the stem leaf plot also, we're supposed to put the leaves in order. So here are my leaves. So I have 1, 2, 3 zeros. 1, 2, 3 zeros. I have 2 5s. And I have a 7. Then in the 60s, I have a 0. I have a 1. I have a 2. I have a 3. Don't have any 4s. I have a 5. I have a 6. I have 1, 2 7s, 2 8s, 1, 2, 3 9s. And then in the 70s, we have a 0, a 1, a 3, a 5, and a 9. So we've put our values on our leaves in order from smallest to largest. So it appears that our smallest value is 50 and our largest value is 79. Now, when I'm doing a frequency distribution, I normally won't go quite through this process of making the stem and leaf plot. Partially that's just for practice for that other skill, but that does help me make sure I didn't overlook my smallest or my largest value. So my minimum is 50, my maximum is 79. So if we subtract those, largest minus smallest, we have a range of 29. So if our range is 29, and we're breaking it up into 6 classes, 29 divided by 6, 4.833. So our class width, we're to round up. If we round down, then we're not going to be wide enough. If we were to round down to 4 and we have 6 classes, then that's going to cover a range of 24, but we have a range of 29. Whereas if I round up and I have 6 classes, that covers an expanse of 30 units. Our range is 29 units, so it's better to be a little bit too large than not large enough. So that's how we get our class width. Now we need to use our class width in order to divide up into classes. So this problem says use the minimum value at the bottom of the first class. So for our class limits, the first class starts with 50. If our class width is 5, then when we add 5 to that, that'll be the beginning of the next class. If we add 5 to that, that'll be the beginning of the next class. 5 more, 5 more. So that's 1, 2, 3, 4, 5. So we need one more. Remember, we have 6 classes. So if we add 5 to that, that's where the last class will begin. Remember what the class limits are. They list, it's a range of values that fall into each class. So if the second class starts at 55, the previous class ended at 54. If the third class ends at 60, then the begins at 60, the previous class ends at 59. So one lower than the starting value of one class is the beginning or the ending for the previous one. Also, you may notice if I add, the difference here is 4, the difference here is 4, 4. So if I add 4 to each one of these, that gets me the upper limit. Also, remember the class width, that's also the distance from the upper end here to the upper end of the next class. So if I add 5, I get this. Add 5, add 5, add 5, add 5. So those are the classes for this particular set of data. Then we're asked for the frequency of each. And remember, all a frequency is the count. How many pieces of data fall in that category. So I'm just going to use the tabulation method. I'm going to take a piece of data, I'm going to find out which class it falls into, and I'm going to make a mark. And then I'm going to mark that piece of data out. 50 falls in this category, mark it out. 55 goes here, mark it out. 55 goes here, mark it out. 57, 79, 60, 62, 61, 63, 66, 67, 69, 69, 68, 68, 65, 67, 50, 69, 70, 75, 71, and 73. So the first group has 3 in it, then 3, 4, 9, 3, and 2. So that's the frequency for each of our classes. Now the next question that we're asked for is the cumulative frequency. Remember, the cumulative frequency is how many pieces of data have we accumulated by the time we start at the bottom and get through each class. So when we have finished the first class, we have a total of 3 pieces of data. If we move on up, we have 3 pieces of data now. When we get finished with the next class, we'll have added 3 more. So we have a total of 6 pieces of data now. So 6 is the number of data elements from 50 up to 59. So then, as we keep on going, we have 6 pieces of data so far. By the time we get through the next class, we've added 4 more, so the 6 we already have, plus 4 more is 10. We pick up 9 more in the next category, so the 10 we already have, 9 more will be 19. So by the time we get through 69, we've accumulated 19 pieces of data. So then when we get to 74, we've added 3 more. And then when we get to 79, we've added 2 more. So those are our cumulative frequencies. Now this particular problem does not ask for the relative frequency, but we're going to go ahead and calculate it just for practice. So if we need to know the relative frequency is the frequency for a given class divided by the total number of points. So there are a total of 24 points. So for the first class, it has 3 out of the 24 points. We could reduce that and get a fraction in reduced form, but 3 out of 24, or 3 divided by 24, is 0.125. So as a proportion, this 0.125 is a decimal. If we want to change that to a percent, move the decimal over 2 places, and that'll be 12.5%. So 12.5% of the data falls in the first category. In the next category, we also have 3 points out of a total of 24. That's the same number of points, so it's going to have the same relative frequency. The next category has 4 items out of the 24. So 4 out of 24.16 repeating. Or as a decimal, that's 16.7%. The next category has 9 out of 24. It has 9 elements. There are a total of 24. So 9 divided by 24, 0.375, or 37.5%. The next category is another 3. So 3, we said, has a relative frequency of 12.5%. And then the last one, that category has 2. So 2 divided by 24.083 repeating, or about 8.3%. So that just lets us know what percent of our data is in each class. We can look at our data and know that the third class has the most number of items in it. We can also look and see as a percent, it has 37.5% of the sample in that category. So I'm going to pause real quickly, put all of these answers into MyMathLab, and then we'll look at the next part of the question. So when we transfer these values over to MyMathLab, it tells us that we got that correct. We put in the classes, we put in the frequencies, and we put in the cumulative frequencies. So the next part of the question asks us to select the corresponding ogive. If we look at the values on the x-axis, notice these are class boundaries. Our class limits don't have any decimals in them. So let's take a break and let's see, well, how do we get the class boundaries if we know the class limits? So remember, with our class boundaries, we don't want to have any gaps. So notice from 54 to 55, there's a gap. Those are consecutive integers, but there are gaps between integers. 54.1, 54.2, 54.3, and so forth. So remember the way we get the class boundaries is we subtract a half unit from the bottom end and we add a half unit to the top end. So if we subtract half a unit from 55, we're at 54.5. And if we add half a unit to the upper end, that gets us to 59.5. For the next class, oops, I skipped one, didn't I? That was the second one. So let's go back to the first one. The first one started at 50, so if we go down one, we're at 49.5. It ends at 54, so if we go up a half, it's 54.5. Notice there's no gap here. There's no gap between where this one ends and that one begins. So we did the second one already. The third one picks up at 59.5, and it continues on to 64.5. The next one starts at 64.5, and it goes on to a half unit past 69, so 69.5. The next one starts there, goes to a half unit past 74, and then the sixth one starts at 74.5 and goes to a half unit past 79. So even though our data does not have half units, none of our data values are going to be at 49.5 or 54.5. But notice everything that is in this class is in that interval as well. If it is 50, 51, 52, 53, 54, all of those integers are in this class. This just makes it where we have no boundaries between our two classes. So it makes it nice and continuous. So when we go to our problem, we want to look and see which one of these graphs match our data. So with an ogive puts a point at the value for the cumulative frequency, and it does it on the right side of each interval. So for example, the first class starts at 49.5, and when we're at 49.5, we have accumulated no data. At 49.5, no data has been accumulated yet. But when we get to the edge of that, when we get to the right side of the first category, we have 3 points already. So we're up to 3. So this one is right so far. When we get to the right side of the next category, then we should have a total of 6. So when we get 59, 59.5, we should have a total of 6. Well, at 59.5, notice that's a little bit, 6 should be halfway in between. That's a little bit lower than that. So the first one's not right. The second one starts at 0 here, that's good. We're to 3 here, that's good. By the time we get to the second category, we're at 6, that seems true. When we get through the third category, we should be up to 10. So by the time we get here, we should be up to 10. That seems right. By the time we get through the next category, we're up to 19. Uh-oh, this went from 10 up to around 21. It should have gone only up to 19, so that one's not it. This one starts out the same as the other one, but from here to here, this one only goes up to 19, which is what it's supposed to do. Then after we get through the fifth category, we have a total of 22 values. And then by the time we get to the very end, 79.5, that's the right the upper boundary for the last category, we have a total of 24 points. So remember, these are the cumulative counts. How many total points have we gotten by the time we get to this age? So by the time we get to 79 and a half, that has accumulated all 24 pieces of data. So if we check, then that is correct. Then we have another question. Where does the greatest increase in cumulative frequency occur? They're asking us in what class. So if we look here, that class has the most pieces of data. So when we go from 65 to 69, or in terms of our boundaries, 64.5 up to 69.5, then we have the largest increase. We have increased the most. From here to here, we went up 3. Here to here, we went up 4. But here to here, we went up by 9. They're just asking us for the class here, not the class boundaries. So the class where that occurs is 65 to 69. So let's make sure that's what they want, 65 to 69. And yes, that's what they're looking for. On the graph, we put the boundaries so that we don't have any gaps on our graph. But in our frequency distribution, when we list what our classes are, since all of our values are integers in our data, we just list the class limits instead of the class boundaries. So hopefully that will help clear things up a little bit, but if you have questions, feel free to let me know and we'll try to clarify things more.